this problem simply asks you to find the x-coordinates or the x values of the critical numbers for this function, which occurs when the first derivative equals 0. Here's the red graph of the original function. This is the graph of the derivative, the green dashed line, and it looks like that derivative is equal to 0 at 1, 0, negative 1, 0, and 1. And there are the points where the original function has a horizontal tangent line. It looks like this is the derivative function. How do we find that out, and how do we set it equal to 0 and solve for x? Well, here's the original function. To take the derivative for the first term, the derivative is 2x. For this term, minus 2 times the derivative of ln of x squared plus 1, but 1 over x squared, quantity x squared plus 1, times the derivative of the inside, the chain rule. And this second term simplifies to minus 4x over x squared plus 1. We want to know, when does this equal 0, or when is it undefined, in order to find the critical numbers. So we set it equal to 0, multiply every term by this denominator, which can never equal 0, by the way, because x squared is greater than or equal to 0 always. So there's what we get. The first term multiplied by x squared plus 1, second term multiplied by x squared plus 1, the denominator cancels out. 0 multiplied by x squared 1 is still 0. Simplify, set it, since it's set equal to 0, we can solve by factoring out a 2x, leaving x squared minus 1. At that point, x equals 0 from here, or x squared minus 1 equals 0. X squared equals 1. By the square root property, x equals plus or minus the square root of 1. Of course, you could have solved this by factoring also, factoring in x minus 1, x plus 1, difference of squares, leading to the same result. Okay, there you go. Hope that helped. If you have any questions, post a comment.